So we looked at matter, different forms of matter, atoms, molecules, solids, liquids, gases, and now we got to talk about energy a little bit. There's different forms of energy, and so maybe in your workbook you would have highlighted or underlined or somehow made a note of these different forms of energy, which is really just the capacity or the ability to move or change matter. So there's kinetic energy, which is energy of motion. Thermal energy refers to, and often we think of like heat, and heat really is a measure of like kinetic energy of particles that make up a substance. How much kinetic energy does a substance hold? And it depends on how many particles there are and how much energy they each individually hold. We'll talk a lot more about thermal energy later, but you can kind of think of it as heat energy. Potential energy is stored, and maybe most important is chemical energy, or at least important to us in chemistry. This is a potential energy that's stored in chemical bonds. It's the bonds that hold the atoms together, and it's really cool because if we want to break bonds and have some kind of a chemical change, then we have to add energy. Energy has to be absorbed in order to break bonds. And if we form new bonds, energy is released. And that's a concept that we'll talk about quite a bit this year. Think about atoms that are bonded together. If they're bonded together, it's because they're somehow more stable being together. And if they're stable together, I think of it as like two strong magnets that are attracted to each other. And if I want to pull those magnets apart, I have to add energy. So maybe we could even kind of mark that in there. That energy is absorbed to break bonds. Break bonds. And you can write in your workbook or wherever you are kind of taking some notes. You can make notes wherever you want to. So I have to separate things that are attracted to each other. That takes energy. But energy is released when I form bonds. Form bonds. Not all atoms bond together. The only times when they bond together is if they form something that's more stable. If they form something that's not stable, then why would they want to do that anyways? Nature favors stability. So if two atoms come together and they can be more stable by bonding together, then energy will be released. And it's a concept that we'll revisit a lot throughout the entire course. And so this little picture kind of just shows some different forms of energy, kinetic energy and kicking the ball, moving the ball. And particles have kinetic energy. And gas particles have a lot of kinetic energy. And maybe we think of solid particles as having less kinetic energy. They still do vibrate. They have energy. It's just not the same extent as gas. Potential energy is, if I were holding a ball on the top of a cliff and I was ready to drop it, there's the potential for there to be change. And we kind of think in chemistry too of like there's potential energy stored in these bonds, that if I could break this bond, maybe I need to absorb energy, or if I could just put these two particles together, maybe there's the potential that energy could be released. And so here we look at a cause and effect cross-cutting concept, CCC. Draw an arrow in the figure of the player holding a soccer ball to show the direction that the ball will move if the person stops holding it. Well, duh, right? And like Newton's laws, and this is some like pretty hardcore physics here. So obviously if she stops holding the ball in your workbook, as you kind of read through this on your own, I'm hoping that maybe you drew an arrow pointing down. That would be the natural tendency for the ball to drop. Thank goodness for gravity. But then more important to maybe chemistry, add arrows to show how the charged particles in the figure will move. And that's definitely something that we'll look at, that often particles have a charge. Even if they're somewhat neutral, they might be partially charged, or there's something I could do to make them charged. And that just kind of aids in the fact that maybe if they're oppositely charged, they would interact with one another. And I guess if they were the same charge, last time I checked, like charges repel, there would still be some degree of interaction. And so here if I've got these particles that are oppositely charged, draw arrows to show how the charged particles in the figure will move. I don't know, maybe I do something that like kind of brings them together. Opposites attract. So if I have oppositely charged particles, that's where the interaction will take place. That would be a favorable interaction. Discuss your reasoning with a partner or with your cat or your dog or yourself or whoever. And so hopefully you kind of explain something along those lines, that opposites attract. And again, that's a favorable interaction.